Lesson number 63 is about the product of square roots rule and repeating decimals. Now our product of square roots rule is an important one that we'll be working with quite frequently in the next few lessons. And it says the square root of m times the square root of n is equal to the square root of m times n. Now I like to take my square root bar and I actually like to make a little hook on the end of it so that we know that's where it ends. You can do that if you like. Now, an example of this product of square roots rule would be like saying the square root of 3 times the square root of 2. Well, that must be equal to the square root of 3 times 2. That's 6. And the nice thing about the product of square roots rule is that we can work in either direction. So if we said, let's say we had the square root of 8, well, the square root of 8, that could be broken down. And the square root of 8 could be broken down into the square root of 4 times the square root of 2. And that's because 4 times 2 is 8. Now the neat thing about this is now we know the square root of 4. The square root of 4 is 2. So the square root of 8 is really going to be equal to 2 times the square root of 2. And this is the way we'd actually want to report our answer for the square root of 8. It's kind of like when we have fractions like 5/10. Instead of saying 5/10, you know we always say 1/2. So we've got to reduce to lowest terms when possible with fractions. We also want to reduce to lowest terms with square roots, just like we've done here. Let's practice that a few more times. Let's simplify the square root of 50. This means reduce it to its lowest terms. So the square root of 50, well, that could be broken down many different ways. I like to break it down into the square root of 25 times the square root of 2, because 25 times 2 is 50. Now the square root of 25, I picked this one for a reason, is because the square root of 25 is 5. So we get 5 times the square root of 2, and we've got our final answer. That would be our simplified version of saying the square root of 50. Now, there's other ways we could have broken down the square root of 50. Square root of 50, we could have broken that down and say, let's say the square root of 10 times the square root of 5. If we did it this way, we'd then have to break down the square root of 10. Square root of 10 would be the square root of 2 times the square root of 5, and we've still got to multiply it by our original square root of 5. Now, well, the square root of 5 times the square root of 5, that's going to get us back to the square root of 25, and then we know the square root of 25 is 5, so we're going to get 5 times the square root of 2. And when we have a problem like this, we'll always write our whole number part out first before we write our square root part. But see, we got the same answer either way, so it doesn't matter which method you choose. But if you choose this one, square root of 25 first, it's only one more step. Whereas if you chose the square root of 10 and the square root of 5 first, you've got a couple steps till you get to your answer. Let's look at another one. Here we have to simplify the square root of 147. Now, 147, you might be thinking that's prime, but be careful, because 1 plus 4 plus 7 is 12. And we know 12 is divisible by 3. So 147 must be divisible by 3. 3 goes into 14 4 times. That's 12. We have 2 left over, and we bring down our 7, and 3 must go into 27 9 times. So we get 49. So the square root of 147 is going to be the same as the square root of 3 times the square root of 49. Now this is a nice one because the square root of 49 is 7. So we're going to get 7 times the square root of 3. Whenever we see a problem with the square root, we always want to see if we can simplify it to its lowest terms, just like we always try to reduce fractions or simplify fractions to their lowest terms. Now, the last slide that we have for today, make sure you get this in your notes, are some common repeating decimals with fraction equivalents, and you might already know these. If we look at them, 1/3 is equal to 0.3 repeating, which is just 0.3333 and so on. 2/3, there's a fraction bar in there, is equal to 0.6 repeating. 1/6, you might not remember that one. If you don't, that's okay. Let's make sure we get all 4 of these in our notes. 1/6 is 0.16 repeating, and only the 6 repeats. Our repetend bar is only above the 6, so 0.1666. And 1/9 is equal to 0.1 repeating, so 0.111. Now again, this is just for your knowledge. Okay? Remember, we do have our fraction equivalence table. Make sure you get this in your notes, because these are very good ones to have memorized. We'll see these over and over and over and over and over again. So if you've got them memorized, it will save you some time. Lesson practice will be on page 259. Make sure you've got your notes complete, and I'll see you during our next class.